Kubernetes for Humans.
Hello, everyone, and welcome to another episode of the Kubernetes for Human podcast. Today, with me in the show, we have Sid. Sid, happy to have you.
Hey, Toad. Great to have you. Great to be here. Yeah.
So, Sid, maybe tell us a bit about yourself. Who are you? What do you do? And what's your favorite Kubernetes object?
Interesting set of questions. So, by way of introduction, my name is Sid. I am one of the founders and the CEO at Hathora. We provide game infrastructure to studios that are building the games. Primarily, our bread and butter is in hosting the dedicated server component, which is the thing that everyone, if you're playing Call of Duty or Halo, you connect to once the match has been found. And this is the server that's keeping all the state that everyone is modifying constantly in sync. We started the company about 3 years ago. We're a big Kubernetes shop at this point. We've tried a few alternatives before settling on Kubernetes, but happy to chat more about that down the line. Prior to this, I was at Databricks, where I was working on multi-cloud standardization, since the platform had to operate in Azure, AWS, and GCP at a pretty large scale. And then prior to Databricks, I was at Palantir, where I led the cloud team. And that kind of preceded Kubernetes. We're mostly like Puppet and Ansible at that time, and mostly not even in containers. So have a good bit of experience even in the pre-container world.
I hope you still have your stocks with you.
Yeah, don't remind me, because there's a 3-year expiry, and it's been more than 3 years since I left, so I had to sell.
Okay. With that, let's talk a bit about maybe starting to think, maybe share a bit about Databricks if you can, right? Like a bit about your journey, because this is where you really started Kubernetes, and multi-cloud is always changing, right? So always a lot of problems. So if you can share a bit about what you did there, and then what led you to start a company in the gaming industry. It's also quite
Sure.
new.
Yeah, so at Databricks, by the time I joined, the company had already started to use Kubernetes for compute. At that point, they were primarily in AWS. They signed a deal with Azure a couple years prior, and the Azure partnership was really starting to take off. And teams were annoyed that they had to ship software and test manually and make sure it worked in AWS and Azure. But it was just two, and they were okay with that. But in 2020, a couple months after I joined, they actually signed a partnership with GCP as well. And now all of a sudden teams are like, are you kidding me? Like, I have to not only test in AWS and Azure, but also test every feature or every update I'm shipping in GCP too. So internally, the platform team kind of recognized that, okay, look, this isn't sustainable. We actually need a centralized team to kind of maintain a consistent interface across all three clouds. And I think everyone knew that was very ambitious. And, I think even in the broader industry, everyone would like to be entirely cloud agnostic. But the reality of it is everything from IAM permissions to, even simple stuff to how container registry permissions are handled are different across the various clouds.
Mhm.
So it really became a challenge of okay, well, let's not promise the world, but let's focus on what are the common pieces that we can start to abstract away.
Mhm.
And so compute orchestration, since we're already leaning pretty heavily on Kubernetes, we started leaning a little more heavily on Kubernetes. We were always using Terraform as well to set up and manage resources. But we started using Kubernetes more for there was a serverless offering that Databricks just shipped. So once we started shipping that, there were some concerns around security, because all of a sudden it was a multi-tenant architecture.
Yeah.
That Kata containers versus Firecracker versus just native container D pods, and then looking into how performance is affected across all three options. So there's a lot of in-depth stuff that happened at Databricks, and the team there was just excellent. And yeah, I left Databricks mostly because my co-founder was chipping away at me for 6 months. We've been really good friends since college. And he was like, hey, I'm working on this thing in the gaming space. I could use your help trying to build the infra layer around it. And then eventually he got me on a good day. And then I was like, okay, let's do it.
Mm-hmm. So you left Databricks. Your partner was already like in the gaming industry, but like to be honest, like I never worked in the gaming industry, right? Like I gamed or quite a lot, but I never really did hardcore gaming. I know there's a lot of challenges in general. So maybe share a bit about what originated or the partner to start this idea. Like what was the background, what was the promise, and a bit about the journey that you had along the way.
Yeah, I think the core of it comes down to my partner started to try to build stateful applications, right? Applications that required in-memory transactions where you couldn't wait to for a database to acknowledge your write. And the more he started thinking about how do these real-time apps work, the architecture for it was pretty poor, and especially when you think about how you scale those. Typically, you kind of, people try to shoehorn the existing load balancer, web apps, and then, a database architecture to those kinds of apps as well. But, if you have two different clients that are connected to the same so-called room that need access to the same state, but they're, load balanced to different servers, the two servers need to stay in sync. So then, you introduce like a Redis or some sort of message bus in between. And my partner looked at this and was just like, this is just obnoxious. In fact, Uber and Figma, Uber was super well known in the industry for using Kafka topics extensively. But then a couple years ago, they posted a whole series of blogs on how they moved away from that and into more of these stateful web servers. To where if two like a rider and a driver were paired, they were physically connected to the same server, so that there wasn't this huge complex architecture that needed to be dealt with. So his kind of passion really came from how do we make stateful application management easier at scale? And as we started looking into it, then, the hosting piece ended up being pretty challenging as well, because, you look at AWS with ALBs or ELBs, or, any of the go-to advice that's given, it's the same, throw a load balancer in front advice. But for gaming specifically, what we discovered is it's the extreme end of this stateful problem that I'm describing. So the dedicated server part that I'm describing here basically is receiving inputs 60 times a second from all the connected players. So, maybe this is a 3v3 match or a 6v6, or in Fortnite, it's actually 64 players at the beginning. So all of those guys are sending updates based on, hey, I moved my joystick this way or I press this button. And then it's the server that's actually reconciling all those actions into what is the actual state of the world. And then it needs to re-emit the current state of the world or the relevant pieces of the world to all the connected players as well. So if you can imagine 60 frames per second, right, that gives you 16 milliseconds to finish the computation. You have no time to write to a database, load that up, and when the physics simulation itself takes up that whole envelope. So it's a very interesting technical problem. And then a lot of these the way these are deployed, containers weren't really being used. The way the underlying hosts were being managed was pretty archaic as well. So we took a look at what other options were available in the industry, and based on what I've seen possible with Kubernetes and containers, I was just like, we can do better here.
So, first of all, super interesting and great explanation on the problem. But listening to what you have to say, it feels like there are two challenges here. There is the technical challenge of, let's say you already built everything to make sure it's up, it is running, the latency is super low, you are not missing any session, whatever. Super infra hardcore problem for a low latency, high throughput application. On the other side, what you're saying is that there's also an architecture problem in a way of too much complexity. And what you're saying is that you're trying to manage both of them, right? You're saying, let's solve both the it's so hard to host and it's so hard to build into a unified solution. Is that correct?
So that's actually what our ambition was at the very start of the company. In fact, it was more of the let's solve the architecture problem, and then eventually we'll monetize that by providing an infra solution.
Yeah.
Over time, we actually built that. It's called Hathora Builder, and that's a software framework that does code gen and kind of makes it really easy for you to state synchronize across multiple connected clients. Think Socket.io, but better. And then we started building the backend component, the infrastructure component to it. And then what we discovered was, you know, the the barrier to entry or barrier to adoption for the software framework was significantly higher than the infrastructure piece. So over time, what we did was we kept stripping down the software piece to make it more and more generic so that more people can be willing to migrate their apps over to the point where we're like, look, like there's nothing of value left here. Let's just provide the hosting offering as a standalone thing. And we still have the builder as an open source like project, but usage for the builder component is like almost non-existent, but then usage for our infrastructure is exploding.
No, that's a very interesting like way, and it does make sense because there are like two very hard different problems I feel that you need to solve in order to do like operate it like in a good way. So
Yeah, at the beginning, we thought about this as like the Spark to Databricks, and we're kind of like building both, where this builder component is like, this new paradigm like Spark was, and then Databricks kind of monetized like actually running Spark at scale. And our infrastructure business was going to be that. But then over time, we discovered that look, like there's actually a tremendous interest in just like stateful infrastructure hosting, even without like providing an opinionated software layer.
okay, so again, like very very interesting, but share it to me. Let's say that you built it and it works, right? Now it's up to you to make, I don't know, like game companies to start using you, right? Like, and those guys, like at least like in big companies, are, I guess, quite strong. They have big budget, right? Like they have a very strong infra team. Share it to me, like why would someone choose you, or how did you start? Who are the first customers? And a bit about like the company growth and like challenges.
Yeah, for sure. I think the one good thing is like we started with a very bottoms up approach. So we didn't instantly say, hey, we have to like win over like
Mhm.
Electronic Arts or Bungie or any of these like larger names. Um, so we were working with essentially hobbyists at the very beginning. The gaming industry is like has tons of hobbyists that, spin up a Unity client. They like want to build a multiplayer game and then they just want to play with their friends. So we're like, all right, cool. Like, how could we just like get the platform working to the point where like a complete newbie can get up and running within a matter of minutes? And over time, we kind of upgraded to like that was like a maybe like 3-month effort for the platform to get to that spot. And then we started kind of putting up a lot of feelers to smaller studios of like less than 10 people. And then there was another 3 to 6 month effort there. And then at that point, we also raised our seed round. And along with our seed round, we brought on a lot of investors that were super well connected in the gaming industry, specifically like venture backed studios.
Mm.
So then, we started talking to a lot of the founders at the venture backed studio level, and we really learned a lot about like their challenges. So I'm talking about games budgets between like 10 to $100 million. And unfortunately, the last year has not been great to those kinds of games that I've launched. But what has been great for us is that these studios are kind of building something from the ground up. And they're usually like, ex Riot or ex Blizzard. And, they're used to having like a central platform team
Mhm.
that they really don't like want to rethink and solve from scratch. And that's kind of where like us coming in has been very helpful. And then the other like really big benefit or like kind of like reason why adoption has been great for us is that if you think about like what goes into building a game, it is one of the most interdisciplinary efforts in the world. So like you have like you have artists, you have your 3D modelers, you have your like motion capture people, you have your like music folks, you have like the story writers, and then engineering is like one component of it. But even in engineering, you have your like Unity or Unreal or like front end engineers who are like handling like ray tracing and like all the physics in the front end, and then you have like your network engineers, and then you have your persistence backend, right? Like at what level am I like what skins do I unlock like that layer. So when you think about the breadth of like what's required to ship a game, it's almost impossible for some of these newer studios to also build the depth required to make an infrastructure offering or their infra piece great. And so by and large, a lot of these companies were interested in buying instead of building in house.
Okay, okay. Let's like everything makes sense. Share with me a bit on like the challenging side, because so far everything sounds quite perfect, right? And like I'm like as a co-founder myself, sometimes life is not perfect, right? Like
Yep.
it can't be the first time that you hear that. So what are like the challenging parts? Is it the technology? Is it getting the customer? All of the above? You tell me.
Yeah. So actually, from a technology, so both me and my co-founder studied computer science at Carnegie Mellon and like have a very technical background. And we were able to assemble like a super stellar like infra team. So like we feel super confident that if technology is ever the bottleneck, which it hasn't been so far, like the tech has always been a little ahead of the business. Like we can solve whatever problems are required. I'm happy to share some of the problems we had to solve along the way. But by and large, at this point, the bigger challenge for us is like customer acquisition, as it is for most startups. And in the sense that the gaming industry is kind of going through a slight contraction. um, Forecasts when we started were, gaming is exploding like 10-20% year over year growth for the next like 5-10 years. But the reality is since like 2023, the industry has been contracting at a rate of about 3%. So that's made it really hard for some of these like newer entrants to break in and like maintain their foothold. And
Mhm.
given that we're a usage-based pricing model, if the games themselves don't do well, like we're not doing well, essentially. So there's ways that we're mitigating against that as well. Starting to like uh, expand up market faster than we had originally planned. And like, we're in really good conversations with like the the massive like studios of the world. But we're also exploring like, we've never like explicitly started the company at the very beginning saying like this is going to be a gaming company and gaming company only. It's very much this like stateful workloads
Mhm.
is kind of what we're interested in. And we're also starting to think about like what additional stateful workloads exist out there. Like, the Figma like interactive application style or like CI/CD workloads or
Figma have like a couple of very interesting blog posts on how hard it is. What was it for them to implement like all of these like features that looks trivial, but they have very, very, very interesting like blog posts on like the technical challenges that you describe, right? Like how do I make sure that when someone moves something, everyone can see it, and how do I publish? And like, no, it sounds like I read it back then, and I was like, yeah, I never thought about Figma as such a hard product to build, right? And it is.
yep, yep. And Figma took a very interesting approach, which is like, broke convention. Like the convention around the time Figma was getting started is like, if you have state that multiple people are modifying at the same time that needs to be synchronized, you either use operational transforms or use CRDTs. And like Figma was like, actually, like, maybe let's not do that. And the reason OT and CRDTs were helpful is that, like, if you had a load balancer and both users were connected to different web servers, OT and CRDTs were actually helpful in resolving the deltas that way. But with Figma, they basically said, no, each Figma document is going to be pulled into memory in one server somewhere in the world. And all editors of that document or viewers of that document are going to be connected to that same physical process. And so that eliminated a lot of this, like, oh, like, what if someone else connected to a different server updated the database before my
Yeah.
write went in? And so Figma's architecture is very similar to the game, like how game servers handle it. And it's just interesting to see like more and more of these like real-time apps are moving towards the gaming architecture than vice versa.
That's cool. Like very, very, very interesting. And again, like as a developer, it always looked not that, it looks a bit trivial, right? But then when you think about it, it is like super complex and so on. And maybe share a bit about where does Kubernetes fit in the picture? Like, are you guys managing it on cloud? Do you have on-prem? You are very, I guess, very latency aware, very network aware, right? Like that's life, right? So maybe share a bit about the technical implementation and but maybe like challenges or problems that you guys encounter.
Yeah, 100%. So let's separate like how we handle our control plane, like our API server and our management layer to our kind of like data plane or like the customer compute that we manage, right? So at its core, what Hathora does is we lease bare metal to our customers. And then if they're starting to run out of the bare metal capacity, we automatically start launching cloud VMs and enrolling it into their cluster as well. Right. So by default, they're saving a huge amount of money by running it and like there's a ton of like network band like egress happening for these games as well. So running exclusively on the cloud becomes very expensive.
Yep.
So what this means is we can't actually use EKS or GKE or any of the cloud managed offerings because we can't enroll our own bare metal nodes outside of cloud.
Yep.
So we kind of went through this whole challenge of like, all right, well, how do we like do Kubernetes, or what's our compute scheduling layer as we started to introduce bare metal into our offering. And we looked into Nomad, we looked into potentially using something like Cloud.io, which has like cheaper rates. We looked into like building our own orchestrator and scheduler as well. But ultimately, we felt Kubernetes was good enough for what we needed at that time. And then what we discovered was like Talos was a very great packaged option here. And then we started talking to the Sidero team, and they basically introduced us to their kind of like managed Kubernetes offering. It's not fully managed, but are you familiar with Omni?
Nope.
Okay. So Omni is a product that Sidera has been working on, which basically allows you to manage various Talos nodes that boot. And like, so essentially the way it works right now is like, we have Talos as the base image that gets installed both on our bare metal servers and as our machine images for VMs as well. So when these boot, they have a join token that lets them know like you need to enroll into this Omni cluster. So they speak to Omni, and Omni is aware of like all of our compute nodes across the world. And then on the Omni side, we can choose to elect each node that has come up as either a control plane node or a worker node. And so Omni kind of makes this like very easy for us to manage the end-to-end lifecycle of the underlying Kubernetes nodes that we're bringing online. And then from there, there's a huge amount of like work that went in on our end of like, how do we schedule new pods in under 3 seconds, where our P95 is under 3 seconds, including container pulls. Right. And these containers are massive. Like, we're talking like 3 to 10, some customers are even above 20 gigs. So like doing a container pull after the pod is scheduled is almost like a non-starter, because that means like in the hot path,
You're lost. Yeah.
yeah, customers matchmaker says, hey, I found, these 6 players ready to play a match. Hathora, give me a game server. And if we're sitting there for like 2 or 3 minutes pulling a container, the players are stuck watching or waiting for the game server to start. So yeah, happy to go into optimizations around like start times, optimizations around container registry pulls. Wherever you want to double click.
And we don't have a lot of time, so I will ask maybe a bit about like, you talked about where are you currently, but I'll be happy, and as like you guys are using Talos, maybe share a bit about where do you think the industry is going from a technical perspective, like a year from now, 2 years from now. What technologies do you believe will make your life simpler? Maybe like, is there anything that is like up and coming in six? Like, I don't know enough like the space, so I'll be happy to learn.
Yeah, I think some of the like, open challenges that we have with Kubernetes still, which I don't really know if they are being solved, like are one is I think the networking model is still not like a perfect fit for us. So between hostport services, hostport, nodeport, and ingress, we basically had to resort to hostport because we just need to expose a port.
Yeah.
But then, for host port, you have to, in the pod spec, you have to specify the host port.
Yeah.
And if there's ever a conflict, like 2 like pod specs with the same host port not be scheduled on the same machine, that's a huge problem for us. And we don't have a way around that right now. So like, we are thinking about maybe switching to like, to ingress and like having like an Envoy container that handles like that, like routing, but it's not fun. So I'm looking for like, ideally what I would want is like, hey, like I would say like, this is my internal port, but like map me to any external port that's available like on this. Like that would be amazing. Then another thing that like we're struggling with is just the like,
Are you using like the default network like a CNI, like for or like Cilium or something like that in general?
we're using Calico. Yeah. But the other thing that we're struggling with is like, okay, like even after we've optimized, let's say like, the image is cached on the machine already, it still takes between like 1 to 3 seconds for a pod to get scheduled and started. And ideally, we would like to get that down to 100 milliseconds, right? And so that goal we've kind of given up on if we use Kubernetes, if we continue to use Kubernetes as a scheduler, because the kubelet like polls, and there's that delay there. And technically now there's an event-driven kubelet that's like starting to come up as well, which we're excited to try when like it's a little more mature. But there's still like a few too many things in terms like Kubernetes. I don't think was designed to be this like
It was really
ultra.
not designed, I think, for that. Like,
Exactly. So that's one piece. And then the other piece is like around like container pools. We run these like very large clusters, like, and if another node already has a container on LAN, we would like to pull that over. So there's a project called Kubefledged that basically does peer-to-peer polls, where each node kind of advertises like which container images that it has available, and then Kubefledged can basically try to pull from that before it goes out to the like open internet and like pulls from your registry. But the support for it is still like a little iffy, and it took us like a lot of effort to like get it working. And then there's some things around, observability and monitoring that I feel like could get better with Kubernetes as well. I'm really hoping like, there's some like RFCs that are out right now that address some of these, but I haven't kept up either.
okay, no, like it's a great answer, and I think your use case is indeed, on one hand, it's quite unique, right? Like it's not what like I think Kubernetes 1.0 had in mind when they released, but it is part of this like bigger movement that I see of like Kubernetes as the new cloud. Like how can I run everything that they could have run using like a cloud or VMs on top of Kubernetes? I don't care if it's like low latency, high resiliency, high throughput network, whatever. Kubernetes just give me the relevant platform in order to support it. So I think like you're really like taking Kubernetes to the edge in like different areas. But I do hope that the platform itself, will keep on growing and to support that. Like even more like even your requirement, like it's quite like beautiful that you are able to use Kubernetes, right? Like very low latency, very like critical workloads, and like very network intensive. So like it's nice that it got you so far, but yeah, I feel that as an industry we have a lot to do.
Yeah. And I'm very grateful for that, right? Like it's not like I don't take that for
Yeah.
granted. I think our requirements are already pretty crazy, and I'm very happy that Kubernetes like is functional enough to the point where our business is successful. But it's one of those things where like 10 years from now, if our business continues to scale at the rate that it's scaling,
I hope.
like, it probably makes sense for us to start investing in our own scheduler at that point instead of relying on whatever quirks Kubernetes has and kind of like waiting for like the community to actually like
Yeah.
make fixes.
Okay. Any last wording? Like do you want to publish something, say something to the to our listeners?
Yeah, well, we are going to be at the Game Developer Conference in San Francisco next month. So if any of the listeners are going to be around, I would love to talk shop with them.
Okay, cool. Which is like usually, like you heard it like during the episode, AI gaming or anyone else that has a very strong, complex stateful application running on top of Kubernetes or not running on top of Kubernetes, and you want someone to take the burden and let like a team of like experts to manage it for him, which sounds quite amazing. Okay, thank you very much, Sid. A very interesting and enlightening episode.
Awesome. Thanks for having me.
Kubernetes for Humans.